Now, moving towards our next session, I welcome Dr. Akansha Singh. Dr. Akansha Singh received the BTech, MTech degrees in Computer Science and Engineering, the PhD degree in Image Processing and Machine Learning from IIT Roorkee. Currently, she is a professor with the School of Computer Science and Engineering, Bennett University, Greater Noida. She has also undertaken government-funded projects as a principal investigator. Her research interests include image processing, remote sensing, IoT, and machine learning. She has served as an associate editor and guest editor for several journals. Welcome, Dr. Kanksha. Over to you, ma'am.
Thank you, ma'am. Uh, Thank you so much for the introduction. A very good evening to all of you. Myself, Dr. Akansha Singh, and today I'll be talking about exploratory data analysis. So, like in the particular FTP, you people have been studying about machine learning models. You have been talking about different models, how the training is done, how we are going to get a better accuracy, and things like that that you've been listening to. But whenever we are going to apply any machine learning model, one of the most important and necessary thing is to make our data applicable for any model. And the other important thing is that whenever we have any model, we want that whatever data we have should be clean. We should know about our data, and then only we'll be able to apply a good model to it. So, whenever we are proceeding with machine learning, deep learning, generative AI, any kind of artificial intelligence that you want to use, the first and foremost thing is that we should understand our data. If we know our data well, we will know what are the constraints in my data, what is the distribution of my data, what is the different kind of, uh, data types in my data. And once you know all that, then it is becomes, really easy for us. It becomes more effective for us to apply the model. So let me just share my screen so that we can go thoroughly through the points. So I think my screen is visible.
Yes, ma'am.
Okay. So today we are going to talk more about exploratory data analysis, where we are going to understand what data is. We need to analyze our data. We need to understand what kind of data we have on which we are going to work. So let's see first what exploratory data analysis is. So if we talk about exploratory data analysis, which more commonly is called EDA, often you will hear the term EDA. So it is basically, a crucial initial step in any kind of data science project that you're going to do. It involves the analysis of the data, visualization of the data, and to understand, what are the key characteristics of my data. It helps you to uncover patterns. It finds out the relationship between the different variables which are there. Then it also tells you what kind of records you have, what is the length of your data, what are the important features in your data, what are the outliers in your data, and how the different variables, are related to each other when we are talking of any of the data that we are going to use. So EDA is normally carried out as a preliminary step before undertaking extra formal statistical analysis or modeling. So any kind of model that you're going to apply to solve a particular problem, EDA is done generally before you apply the model, and it helps you to understand the data in a better way. So formally, if we want to define EDA, we can say that exploratory data analysis is used by data scientists, and it is used to analyze and investigate data sets and summarize their main characteristics, often employing data visualization methods. So many times we have seen that the data set that we use in machine learning or any data science project, nowadays with the kind of data generation we have, we see that the data has thousands of rows and hundreds of columns. And when I have such large amount of data where I have thousands of rows, hundreds of columns. So to go through that, and generally if you see the data will be in a CSV file, an Excel file or things like that. And if as a, suppose I'm a business owner and I go to a person and ask, okay, this is my data, I have this problem, please do solve it for me using some AI tools or something. So as a person, if I go through that data and I see that there are 10,000 rows in my data, if I keep on scrolling on that data and I try to see what are the features, what are the each row contains, that becomes a very difficult task for me to analyze. Rather than instead of that data, if I show you some charts, I show you some graphs, I give you a summary that okay, these are the rows, this is the average of a particular column, this is the standard deviation in a column, it becomes much easier for me to understand. And once I understand the data, it will become much simpler for me to identify, okay, which model should I use in my data. Suppose I have a data and I say, okay, it is labeled data. I simply come to know that, okay, I can use some supervised learning model. Then if I in my data I see, okay, there are a lot of categorical variables, so I come to know, okay, which type of model I should use. If there are more numerical, something that I have to predict is a numerical value or some continuous value, I know, okay, now I should go for regression. So all that confidence is going to come to you once you understand the data, you visualize the data. Because if we talk of earlier times when we had small amount of data where we had 30 rows and two columns, it was easy for us when we were using Excel files and Excel methods for analysis of the data. That time it was easy because we had a limited amount of data and that data was in an understandable form. But now the amount of data that we have, if I go and solve, suppose I'm making a recommender system where I have data of 10,000 clients. In that case, it will be very, very difficult if I can simply keep on scrolling the data and looking at them in different ways. So in for that case, EDA comes into picture, and EDA helps us drastically to visualize the data, to understand our data, to summarize what are the main characteristics of our data. So, if we look at the key aspects of EDA, the key aspects of EDA include distribution of data. That means we can examine the distribution of data points. We try to understand their range, the central tendencies, including mean, median, and the dispersion or variance and standard deviation. So, when I understand the distribution of data, that is a very, very important point whenever we are using any data. Because suppose I have a data of survey of thousands of people. Maybe I want to launch a new product, and for that new product, I have done some survey and I have the data of thousands of people. Now I want to understand that okay, what is the age of the people who have participated in the survey. Suppose I have come up with a very funky kind of a mobile, and I see that okay, data has been collected, survey has been done by my people, and now I try to see and I want to know what is the age group of the people who have participated in the data. So I will try to find out the distribution of the data. So with distribution of the data, I will get the range. So okay, I see a pictorial representation where it shows me that the age column in your data lies from the range 20 to 30. So once I know, okay, I have done a survey for the age group of 20 to 30, now I better know about my data and I say, okay, if I'm going to get these kinds of results, my marketing should be targeted to the people who are of the age group 20 to 30. Maybe I have a new intern who has collected the data from people in the range of say 60 to 70. And then I put all the data in the model and once the data gives me some predictions and they say, okay, this product is not good for people, they will not like it. But when I do the exploratory data analysis, I see, oh, I have launched a product for the youth, but my survey was done on a age group which was in the range of 50 to 60. So there and then only I will understand, okay, this data is not good for me. Either I should change my data, I should do a new survey. So these kind of insights, these kind of data distribution, we understand with the help of EDA, and they help us to further improve our modeling. Then there are a lot of graphical representations also in the EDA, which include utilizing charts like histograms, box plots, scatter plots, bar charts to visualization relationships, and they also help us to understand the distribution of variables. So, with the help of histograms, I can understand, okay, what is the value of the frequency of a particular value occurring. With the help of block plots, I find out what are the outliers that are there. With the help of scatter plots, also, I try to find out what are the outliers. And then we have bar charts, which help us find out the relationships. And similar to these, we have a lot of other plots and charts, which gives us a graphical representation of the data and help us understand that how the data is going to behave. Then another important key aspect of EDA is outlier detection, where we identify the unusual values that deviates from other data points, and these outliers can influence our analysis, and they may indicate, data entry errors or unique cases. For example, in my data, if I have a age column, and by mistake while doing the data entry, someone has put in a negative value. So if I put in a negative value in the age column, that means there is some problem with that particular value. And if I do not do EDA initially, I will feed that data into my model. That one particular negative value might lead to significant accuracy loss in my model, or some kind of wrong kind of predictions can occur. So with outlier detection, I will know, okay, these are the outliers. I need to handle these outliers in some way. Similarly, if I have a gender column, in the gender column I can have two or three values, male, female, or not defined kind of a thing. And somebody by mistake has put the value boy, girl. So again, there will be a deviation in the range that we are expecting. So outlier detection helps us in identifying what kind of unique values or some data entry errors are there in my data. Then another key aspect of EDA is correlation analysis. And when I talk of correlation analysis basically helps me to understand the relationship between the variables, that how one variable will affect the other variable. So there could be a negative correlation between two variables, which tells me that, okay, if one variable is going to increase, the next one is going to decrease. Similarly, there could be a positive correlationship between variables, which tells us that, okay, if one value is going to increase, the other value is going to also increase. It also helps us in computing the correlation coefficients. And once I calculate these correlation coefficients, I know that what are the significant features in my data that are affecting a particular output. So correlation analysis helps us to understand the relationship. It helps us to understand what kind of relationship is there between the variables, what are the significant features in the variables. So all these things I have with the help of correlation analysis. Then another important thing is handling of missing values. For example, if I am detecting and deciding how to address missing data points. So many times what happens is when we are collecting the data or the data is coming from different sources, there might be chances that some of the values are missing. That means I do not have any value for a particular row or column, particular cell. So in that case, when we are doing more statistical analysis or we are feeding that into the model, because of those null values or blank values, when my models are going to calculate the mathematical things, there we might see that there is a unexpected exception that might occur. So before feeding any data into any model, it is uh, advised and it is required that we should find out what are the missing data points in my data, and then how to handle those missing data points. Either we drop those rows, or we use imputation, or we try to fill in those values, and that particularly depends upon what data you have, how that data is going to impact the amount of missing data, and accordingly we choose a methodology to overcome the missing values. Then another important aspect of EDA includes summary statistics, which has calculating key statistics that provide insights into the data trends and nuisances. That means it is going to tell you what is the average of a particular column, what is the mean value, what is the median, what is the standard deviation, what is the data type of that particular column. So all these kind of key statistics we can get with the help of summary statistics. Then we have testing assumptions also. So many statistical tests and models assume the data meets certain criteria like normality. So EDA helps us verify this assumption that whether our data is normalized or not. So these kind of things are helpful with the help of EDA. Then the important question arises that why exploratory data analysis is important. So we've been talking about exploratory data analysis, what it is, what are the key aspects. But one of the major thing that we want to know about exploratory data analysis is the importance of exploratory data analysis. That means we want to find out why exploratory data analysis is actually important for us. So exploratory data analysis helps us in four major ways. First thing is it helps us understand the data structures. Then it helps us identify the patterns and relationships. And it also helps us in detecting the anomalies and outliers. And it also helps us in testing the assumptions. So when I talk about understanding the data structures, EDA helps in getting familiar with the data set. That means we understand what are the number of features, what are the different data types of each of the features, what is the distribution of the data points, and all this understanding is crucial for selecting appropriate analysis or prediction techniques. So we have to see that what kind of data structures are used. For example, if there are mostly numerical values, then what kind of a data set I should use? If I have a lot of categorical variables, then what kind of model I should use? How I should, map those categorical values to different numerical values, because any model that you will use will require numerical values only. So if I have any kind of categorical values also, I have to basically transform them into some kind of numerical values. Then it helps us in identifying the patterns and relationships. So through, various visualizations and statistical summaries, we will be able to identify that what are the patterns, what are the relationship between the different variables. And these insights can guide us further for analysis and enable more effective feature engineering and model building. Then it helps us in detecting anomalies and outliers. That means EDA is essential for identifying errors or unusual data points that may adversely affect the results of your analysis. It helps us detect these early, and it can prevent costly mistakes in predictive modeling and analysis. So if there are some unusual data points, there are some errors in my data points, all these things can be handled before getting into any model, so that we are able to analyze the data properly and we are able to apply that particular data into any model. Then it helps us in verifying whether a particular assumption is followed or not, because in many of the tests and statistical methods that you see, there are some assumptions also. Those assumptions could be the data should be normally distributed, the data should be bimodal, the data should have some kind of homogeneity. So there are different tests and there are different assumptions for these tests. With the help of EDA, you can verify whether your data is following a certain distribution, or which is the independent variable, which is the dependent variable. All these kind of assumptions can be easily understood with the help of EDA. Then it also helps us in informing feature selection and engineering. So the insights gained from EDA can inform which features are most relevant to include in a model and how to transform them to improve the model performance. That means we have to, with the help of different methodologies that are available, we can understand that which are the features that are most important in my case, what features should be followed, and then we should understand that how we can transform them, whether we need some kind of scaling, whether we need some kind of encoding, which can help us in improving the model performance. Then the next important thing is optimizing model design. By understanding the data characteristics, analysts can choose appropriate modeling techniques, decide on the complexity of the model, and better tune the model for different parameters. Then important thing is it also helps you in data cleaning. Many times we have raw data or we have data coming from different, sources. We can have data coming from a sensor, we can have some image data, some video data, which is all combined and a data set is created. So when we have this all process of creating the data, sometimes there are a lot of missing values that could be due to the error during the data collection. There could be a typo mistake, or there could be some unavailability of a data. So all these things lead to missing values. And with the help of EDA, we can facilitate that data cleaning and we can address them before, so that we can have a better quality of data. My data has high integrity. Then enhancing communication. So visual and statistical summaries from EDA can make it easier for us to communicate our findings, and it helps you to show people what kind of data you have. You can convince others easily with the kind of conclusions, and especially when you are explaining data-driven insights to stakeholders without technical backgrounds. So if a person is without a technical background, if you show him a big Excel or CSV file, he might get confused and will not understand many of the things. But if I show him in the form of a chart, a graph, or some kind of plot, that makes a better impression on stakeholders, and they are more likely to understand what you are trying to show them with your analysis. So if we look at a typical process of EDA, the EDA process consists of these steps. First step is we have to look at the data, then we have to clean the data, then we have to make the summaries, visualize the data, ask questions, and find answers. So when I say look at the data, that means I have to gather information about the data, such as the number of rows and columns, the type of information each column contains, and this includes understanding single variables and their distribution. Then the next step when we are talking of exploratory data analysis is after knowing about my data, what are the rows and columns, what is the type of information each column includes, then the next step is that we try to clean the data. So when I'm talking of cleaning the data, in cleaning the data, we fix issues like missing or incorrect values, pre-processing, and making our data ready for any kind of analysis. So all this is included when we are talking of, sorry, when we are talking of cleaning the data. So then the next step that we follow is make summaries. That means we have to summarize the data to get a general idea of its content, such as the average values, common values or value distribution, calculating quantiles, checking for skewness, and providing the insights into the data distribution. Then the next step is we visualize the data. So using interactive charts and graphs, we make those charts and graphs, and with the help of those charts and graphs, we spot the trends in my data. I try to find out the relationship between the different variables. And there are Python libraries like Pandas, NumPy, Matplotlib, Seaborn, etc. that we can use for visualizing the data. Once I know about my data, I have cleaned the data, I have seen the summaries, I have visualized the data. Next is we ask questions from the data, and those questions help us, to understand the data better. So we basically formulate questions based on the observations, such as why a certain data point differs, or if there is a relationship between different parts of the data. So we try to frame such questions. Once we frame such questions, then our next step is to find answers. So we, whatever visualizations we have, whatever summaries we have, we try to dig deeper into those data. We answer these questions, and it could include further analysis or creating models that could include regression or linear regression models. So when we are talking of exploratory data analysis, there are basically three major kind of exploratory data analysis, and the last three that I have put up here are some additional techniques that we have, and all these three will also fall under this. So majorly we say we have univariate analysis where we analyze a single variable. We have bivariate analysis where we try to find out the relationship between two variables, and when I say multivariate analysis, that means multiple variables will be involved, and I will try to find out the relationship between all these. Along with these, we have visualization techniques, which are used in univariate, also, which are used mainly in bivariate and multivariate analysis. outlier detection, which is again used in bivariate analysis, and we have some statistical tests, which can be used in bivariate as well as multivariate analysis. So when I talk of univariate analysis, univariate analysis basically focuses on a single variable to understand its internal structure. It's primarily concerned with describing the data and finding the patterns existing in a single feature. And this sort of evaluation makes a specialty of analyzing character variables inside the record set. And it involves some kind of summarizations, visualization. These help us understand a particular variable. So the common technique could include histograms, box plots, bar charts, and summary statistics. So as the name says, univariate, that means we are focusing on a single variable only. So if I want to understand a particular feature in my data, I will try to do univariate analysis. Then the second type of analysis that we have is bivariate analysis. And in bivariate analysis, this involves, the exploring the connection between two variables. So when I'm talking of these two variables, I will be able to find out the association between the two variables. What is the correlation between these two variables? What are the dependencies? How both the variables are related to each other? All these things can be understood with the help of bivariate analysis. So it is crucial form of exploratory data analysis and it examines the relationship between two variables. And some of the key techniques used in bivariate analysis include scatter plots, correlation coefficient, cross tabulation, line graphs, and covariance. Then when we talk of multivariate analysis examines the relationship between two or more variables in the data set. It aims to understand how variables interact with one another, and it is crucial for most of the statistical modeling techniques that we use, and it includes pair plots and principal component analysis. So there are some tools for performing exploratory data analysis, and these tools include Python libraries, pandas, which provides extensive functions for data manipulation and analysis. It includes data structure handling and time series functionality. Then there is another library in Python which is called the matplotlib. So with matplotlib also, it is a plotting library for creating static, interactive, and animated visualizations in Python. Then another library that we have is Seaborn, which is built on top of Matplotlib, and it provides a high-level interface for drawing attractive and informative statistical graphics. Then we have Plotly, which is an interactive graphing library for making interactive plots and offers more sophisticated visualization capabilities. So in the visualization techniques, we have different visualization techniques which helps us depict the data distribution, trends, and associations. So there are multiple charts and graphs such as bar charts, line charts, scatter plots, heat maps, which are used to make data easier to understand and interpret. Then in outlier detection, EDA involves identifying outliers within the data, anomalies that deviate significantly from rest of the data. And there are tools such as box plots, Z-score analysis, scatter plot, which help us in understanding and analyzing the different kind of outliers that we have. Then there are statistical tests also that are there. So EDA often includes performing statistical tests to validate hypotheses or discern significant differences between the groups. These tests include p-test, chi-square test, and ANOVA, and these add depth to the analysis process by providing a statistical basis for the observed patterns. So there are some challenges also which we face when we are trying to do exploratory data analysis. And these challenges include addressing high dimensional data, data imbalance, and noisy data sets. So let's see. So when we are talking of handling high dimensional data sets, so high dimensional data set is basically difficult. The challenges that we face with high dimensional data is that it is difficult to visualize and analyze many features, because if I have, say, 100 features, then it becomes difficult for me to visualize and analyze multiple features. So the curse of dimensionality reduces the model performance. So curse of dimensionality is a very common term in machine learning, which says that if you have high dimensional data and if you do not reduce the dimension, then that high dimension becomes difficult to compute, and it leads to the degradation of your model performance. So the solution for that is we can use dimensionality reduction techniques, which include PCA, which is available in EDA. We can do feature selection using correlation or importance score. So using correlation matrix and correlation coefficient, we can select the important features. And there are visualizations also available in EDA, like pair plots and heat maps, which are going to help you understand that how you can overcome the problem of high dimensional data. Then the next thing is dealing with data imbalance. So what data imbalance does is, the problem that we face is there is a bias towards majority class in the classification task, and we have reduced ability to predict minority class outcomes. So many times when we have a data set, there is a data imbalance. By data imbalance, we mean that if I am talking of, suppose in my data there are two classes, A and B. So maybe class A has more number of samples as compared to class B. So maybe if I have 1000 rows, out of those 1000 rows, 800 rows are for class A and just 200 for class B. So in this case, when I'm going to apply training on that particular data, in that case, automatically there will be my model will be trained because of the data in such a manner that it will show the bias towards majority class, and it will not be very well trained to predict the minority class. So for this case, using AD, so when we are going to apply the data to any of the models, before that, when we perform EDA, we also check the class imbalance. So when you check the class imbalance, if you see there is a class imbalance, we apply resampling techniques like SMOT. And so in SMOT, basically what we do is some fake data is added for the under or the minority class, and we also perform undersampling, where we reduce the number of sample of the majority class. We assign class weights during model training, so we know what kind of class imbalances. So initially only you can apply some class weights. We can use appropriate metrics like precision, recall, F1 score, ROC, and we visualize the class distribution with the help of bar charts and pie charts. So if we do all this, we will be able to overcome the problem of data imbalance also. Then another problem or challenge that we see in EDA is dealing with noisy data. So many times the challenge is that we have outliers, we have incorrect entries, we have missing values. So all these problems lead to the reduction of model performance. So the solution for this is we can apply outlier detection using box plots and Z scores, and we can apply smoothing techniques like transforms and some kind of rolling averages, and we analyze distributions and relationships to detect anomalies. Right. So once we know about all this, what we are going to do next is we are going to do some hands-on where we will see how actually EDA is applied to data. And we will you do that using Python, because Python is the most commonly used language nowadays, which is being used for any kind of machine learning algorithms that we are using. So I'll just share my Python code with you so that we can start on and we will try to apply some EDA techniques. So let me just unshare my screen and then I will share again. Okay. So what we are going to do is we are going to start with univariate analysis, and with the help of first we will see univariate analysis, how it is done in Python. Then we will come to bivariate and multivariate analysis. So if you look at the code, this notebook, we are going to study about the summary statistics, and we will see some visualizations also, which are done in univariate analysis. So as we discussed earlier, univariate analysis basically works when we are trying to analyze a single variable. So first thing that we do is there are some important libraries available in Python which are used for exploratory data analysis. So first thing, if you see, we are importing pandas as PD, import matplotlib.pyplot as PLT, and import cbond as SNS. So I'm doing it in Google Colab. Those who are interested in doing the hands-on along with me, you can please open up your Google Colab, and once you open up your Google Colab, you are going to write these three import statements, which are pandas, matplotlib, and cbond. And when I run this code, I will see that these libraries or these things are imported into my Google Colab notebook. In case these are not installed in your Google Colab, you will have to use pip install to install them. So if in your case, if it shows some error that it is not installed, you can write like this: pip install pandas, matplotlib, and cbond. So if you will write this, it will import. In my case, since it was already installed, so these have been successfully imported, and I can see a correction sign over here. Then initially, let's make up a data set. So I have created a data set where I have used the variable data, and I'm saying is equal to, and I have made two columns in my data set. First one is age, the second one is gender. So just for the purpose of understanding how the different tools are, different techniques work, I have created a data set. So in my data set, I have two columns, age and gender. In age, I have put some values, numerical values like 23, 25, 31, 35, 28, 40, 50, 29, 37, 45. So just to create a random data set, I have put these values. Next column that I have is the gender column. And in the gender column, again, I have filled male, female, male, female, male. So some random male, female values. Now in my data set, I have two columns, age and gender. In the age, there are some numerical values. In gender, there are some values which are related to gender. So the first column that you see is a numerical column because it has all integer values. The second column that you see is a categorical column because it has the categorical values, either male or female. And then I close the braces so that this particular data is created. Once I create this data, I convert it into a pandas data frame. So the pandas library works has a lot of sorry. So the pandas library has a lot of functions, or we can say a lot of functions which can be used for the analysis of the data. And any pandas help you to create an array, convert an array into a data frame. When I say a data frame means you will have data in the form of a table where you have rows and columns. So I'm going to write df is equal to pd dot data frame data. So I've passed this data into pandas data frame, and now this df has become a data frame. So if I run this, so we can see now we have a table-like structure where I have two columns, age and gender. Age has some numerical values and gender has some categorical values. Now, if I want to do some summary statistics, by summary statistics, I mean, suppose I want to understand the distribution of this numerical data. So suppose I have this age, I want to find out what is the mean value, what is the median value, what is the mode, what is the minimum and maximum value. So I want to find out the range of values in this age column. So simply there is a function in this which is describe. So if I'm going to write over here summary stats is equal to df, and for which column, because I have only one numerical column age, so I am going to write age dot describe. So with the help of this describe function I will be able to describe all the statistics of my age column. And then I print summary stats. So all the description which has been calculated with the help of describe function will be printed. And since it is stored in the summary stats, so it will print the summary stats. And if you see separately also I can find the mean, median and mode. So I'm writing mean age is equal to this df age dot mean function dot median function dot mode function. So it will calculate that also. And if I run this, so it is going to show me the statistics. So with the describe function, you can see it is telling me count, that is how many number of values I have, how many rows are there. So it is telling me there are 10 rows. The mean value of age column is 34.3. The standard deviation is 8.78. The minimum value is 23. 25% quartile is 28.25. Like this, it is telling me the other quartiles. Then the max value tells me that the maximum value in my age column is 50. And separately also, when I'm trying to find out the mean, mode value, mean and all these values, I have calculated the mean also separately. So if you see over here, it is showing me the mean age is 34.5, the median age is 33, and the mode age is 23. Right? So this is how I can find out the statistics also. Now, once I find out the statistics, then I can do some other, then I can do some other visualization also. So if I go to the visualization, so first visualization that we do is a histogram. So in Python, I can make the histogram also. So suppose I want to plot the histogram for age column. So I am going to use PLT, and this PLT is the pyplot function that pyplot library that I have imported in Pandas. And inside PLT, we have a function which is the hist function. So this hist function helps us to understand the, to draw the histogram of a particular uh, column that we want to find out. So I am going to make the histogram of DF, and in that DF I want to create the age. And then I'm giving bins is equal to 5. That means I want 5 different groups, edge color black and alpha zero point 0.7. So this basically tells you the width of the bar that is going to be created. And then I am saying plt dot title. That means title of my graph should be age distribution. Similarly, I'm saying plt.x label. So plt.x label, I'm saying it should have the labeling of the x axis should be age, and the labeling of the y axis should be frequency. So I have given that as the labels. And then I'm saying plt.show. So when I write plt.show, it will show me the graph. So if we run this particular histogram, you can see it is showing me the age distribution. And in the age distribution, we can see we have created 5 different categories. So 25 to 30, 30 to 35, 35 to 40, 40 to 45, and 45 to 50. So it is telling me for each age group how many values I have. Now, with the help of histogram, we are able to understand how my data is in a particular column, particular uh, feature, what is the distribution of the values or what is the frequency of the values. So histogram helps us to understand a particular feature, what is the frequency of that particular feature. Similarly, another plot that we have in univariate analysis is a box plot. The box plot helps us to identify the outliers, and it also helps us understand the spread of the data. So For box plot, we have another library in Python, which is called the Seaborn library. So we are using that Seaborn library, which is SNS. And in SNS, I have a box plot function already present. And in this data, I want to give the data as DF, that is my data frame that I've created. And which value I want to analyze. So I want to analyze the age column. So I've given X is equal to age. This is the standard format. You have to follow this syntax. Then plot title I want to add as box plot of age. And then I'm saying plot dot show. So it will show me my plot. So in this case, now you can see that I have created a box plot. And in this box plot, you can see there are no additional values which are over here, something over here or something over here. If we have some additional values, then that means there are some outliers. So let us see over here and some, let me change one value. So suppose starting from the beginning or in this particular, right now I do not have any outliers. So suppose I make one age as 135, which by mistake maybe during the data entry that was done, and maybe one value I have as 4. So these are some outliers because they do not lie in the range. And once I have this data frame, let me go and try to plot the box plot again. Now in this case, you can see there are two values which are coming outside the box plot. So there is one value over here and one value over here. So with the help of this, I understand that these two are the outlier values. Why these are outlier values? Because these are some extreme values. So all my values are lying in the range 20 to 40 or maybe 25 to 40. But these two values, one which I had taken as 4 and the other one which I had taken as 125, they are coming outside my box or outside my range. So with the help of box plot, we are able to identify the outliers also, right? Similarly, if I want to create the bar chart, let me just fix the values again so that we see other things properly. So I'm changing this back to 35 and 40, right? Now, let's create a bar chart. So bar chart is going to help you visualize the frequency of the categorical variables. So with histogram, we were doing the numerical values, but since I have some categorical variables also, so if I want to see how these categorical variables are distributed, I can use the bar chart. Histogram will work on numerical values. This is going to work on better on the categorical variables. So although both will look similar, so suppose I'm saying gender counts, I've taken a variable over here, gender counts. In that I'm saying df gender dot value underscore counts. So what this value underscore counts is going to do, it is going to count how many values each of the unique categorical variable has. That means how many male values are there and how many female values are there. And then I'm saying gender underscore counts dot plot. So whatever I've counted, I want to plot a bar graph of it. The colors that I'm using are blue and orange for the different graphs. And again, alpha is equal to zero point 0.7. That is the width of the bar. The title of the plot I want to use as gender distribution. The X label can be labeled as gender. The Y label will be labeled as frequency. And finally, I'm saying plot dot show. So if I run this, you can see it is showing me how many males are there and how many females are there. So I can see the count of male and female over here with the help of a bar chart. Then we can also have a KDE plot. These KDE plot provide a smooth visualization of the data distribution, how my data is distributed. This KDE plot will help me to understand that distribution. So the KD plot, or it is also known as the kernel density estimate, which is, helps us in visualizing the distribution of observations in a data set, and it is analogous to histogram only. It represents the data using a continuous probability density curve. So for creating the KDE plot, we again use the Seaborn library. In the Seaborn library, we have the KDE plot function available. In that, we are passing the data frame and we are saying we have to visualize the age column. Fill is equal to true. That means it will fill with some color, and color is equal to green. And plot title is equal to KDE plot of age. And then I'm saying show the KDE plot. So if I'm going to run this, I will see what kind of a KDE plot I'm going to get. So we can see the histogram was showing us some bars, but this KDE plot or the kernel density estimate plot, it gives you the smoothened version. That means it will show you in the form of a distribution. So it shows how my age values are distributed over the range. Right, so this is univariate analysis where we till now we were only focusing on a single variable, and in this single variable we have seen how to see the data distribution, how to see the different statistics of the data. All this is understood using univariate analysis. After univariate analysis, we are going to talk about bivariate analysis, and we will see how bivariate analysis can also be done using Python. So in bivariate analysis, we basically find out two variables, or we try to, analyze two variables, the relationship between these variables. So in bivariate analysis, we examine the relationship between two variables, and the techniques covered include a scatter plot, correlation coefficients, cross tabulation, line graphs, and covariance. So let's see how we can do bivariate analysis in Python. So for this also, we are going to import some of the popular libraries of Python which are used for EDA, which include pandas, numpy, matplotlib, and seaborn. So again, we have imported these and we are going to run this column. So once you run this, you will be able to import these libraries in your notebook. If these are not available in your notebook, you will have to use pip install to install them. Okay. So again, I have created the same data set which we were seeing earlier, which was age and gender. Now we have added one more column to it, which is salary, so that we have a data set which we can see how two variables will be included. So again, I have created a data array which has data, age, salary, and gender. So age and salary are two numerical columns, and gender is a categorical column that I have. So again, I have some age values from 23 to 50, and I have some salary values associated with each age, and I have a corresponding gender also. So again, I'm converting this data frame into this data into a pandas data frame. So let me run and let's see what do we get. So we are going to get a data where you can see now we have three columns: age, salary, and gender. The age has some numerical values, salary has numerical values, and gender has a categorical variable. Now we want to plot a scatter plot which helps us visualize the relationship between two continuous values. So suppose we want to see that how age is related to salary, or what is the impact of age on salary, or vice versa. So if I want to understand the relationship between these two variables, I can use a scatter plot. So plot is going to help me understand the relationship between two continuous variables. So if I want to create the scatter plot, for creating the scatter plot, we have to use two continuous variables. So age and salary are two columns. Alpha is equal to zero point 0.7. Again, I'm giving the width and all these. This is for the formatting purpose. This can be changed, and there are a number of options available. In the plot title, I will write age versus salary. In X label, I am plotting age. In the Y label, I am plotting salary. And plot grid is equal to true. So to show this grid feature and plot dot show. So if I run this, I will get a scatter plot. So if you see the scatter plot, how the scatter plot is showing you that, okay, at the age of 25, the salary is somewhere between 25 and 30,000. At an age of 23, the salary is 25,000. Similarly, like this, we have created a scatter plot. So we can see that the salary is increasing as the age is increasing. So with the help of a scatter plot, we are able to understand the relationship between two variables, which is age and salary. And what relationship we can see over here is that as my age is increasing, my salary is also increasing. So this earlier when we were doing univariate analysis, we were talking of a single variable only. But with bivariate analysis, we are able to see the relationship between two variables, right? So one important aspect that we have is a scatter plot, which is used for this kind of a relationship understanding. Next, we have a correlation coefficient. So the correlation coefficient quantifies the relationship between two variables. A value close to 1 or -1 indicate a strong relationship. So if you look at the scatter plot, we were able to see that there was a relationship, but how much one variable is going to affect the other was not known to us. We cannot find out a factor by which we can say that, okay, the if the age increases, the salary will increase by this factor. So how much effect age has on salary, we do not know with the help of a scatter plot. We only see that there is some relationship between age and salary. But when we have to find out that what is the factor or how much the age is going to affect the salary, we can calculate the correlation coefficient. The correlation coefficient is going to help us understand the relationship between two variables and how much they are. Basically, we are trying to quantify the relationship between them. So, if the value of 1 or -1 indicates a strong relationship, that means if we have a value of correlation coefficient as +1, that means there is a high correlation, positive correlation between two variables. And if I have a value of -1, it indicates that there is a high negative correlation between two coefficients. So to find the correlation between age and salary, again we can use the function CORR, which is called core. So I have two columns age. So I'm saying DF age dot correlation DF salary. So this is going to calculate the relationship between age and salary. It will quantify. And if I will print, I will get the value. So if I run this, so it is showing me that the correlation between age and salary is 1. That means they both of them are strongly related to each other. And since this is a very small data set, so it is showing me a value of 1. Otherwise, if we have a large data set, we get the value in points also, which we will see further in our analysis. Then there is another method which is used for bivariate analysis, which is called cross tabulation. So with the help of cross tabulation also, we will be able to find out the relationship between two variables. So if the earlier correlation coefficient was used when we had numerical values, now if I have categorical variables, I can use the cross tabulation method. With the help of cross tabulation, I will be able to understand the relationship between categorical variables. So in our data set, we had only one categorical variable, which was gender. So if I want to find out the relationship between two, let me add another column, which is experience level. And I have written the experience level. I've given some categories, junior, mid, and senior. I've added one more column over here. And if I print df so that you can see how your data set data frame looks like, we will be able to see that. And right. So if I run this, so now you can see my data set has one more column, age, salary, gender, and a experience variable. So now there are two numerical variables and there are two categorical variables. So for numerical variables, finding the relationship between them, we had used correlation. For finding the relationship between categorical variables, we can use cross tab method. So for finding the cross tab, again we use the pandas library which has a function cross tab, and in that cross tab I'm passing gender and experience level. So I want to see that whether gender and experience level are related to each other or not. And then I'm going to print this cross tab. So let us print this cross tab. So if you see, it is showing me that in female, the junior level is 1, the mid level is 2, and the senior level is 2. And for male, there are two junior positions, one mid position and one senior position. So this is going to cross tab is going to show what kind of relationship they have. That means how many females are junior, how many females are senior. And if you want to see the heat map, which is going to show you how the gender and these positions, how much impact they have, we can use heat map. So in heat map, again, we use SNS and that is Seaborn. In that we give heat map, and within the heat map, we have to pass this cross tab that we have calculated. And annotation is equal to true. That means I will have annotation values. This C map is the color map to select what kind of color you coding you want to use. And then plot title I'm giving as gender versus experience level, and then I'm saying plot dot show. So if I'm going to run this, we are getting one heat map, and this heat map shows us that it basically the cross tab that we have created, it is visualizing that same cross tab. Since I over here we have very limited amount of data, that is why you can see pure blue and red color. But when you are going to have a large data set, you will see the shades will the strong correlation will be given by dark blue color, and as it increases over here, we will have the different range of values. Then we have line graphs also. So these line graphs are useful for time series data or visualizing trends between two variables over time. So if I want to see how, time series data means if you have some data for different periods of time, that means, for example, stock prices, we are collecting from for each day of each month of each year. So that is a kind of time series data where you have a data over a period of time. So if you want to visualize the time series data or we want to find out the trend between two variables over time, we can use line graphs. So line graphs can also be easily made. So first we are adding a time like variable also. So I've added DF year range 2010 to 2020. So when I write range 2010 to 2020, it will automatically take some values in the range 2010 to 20 for all the columns. So I'm randomly adding that. So let me print this data first. So you can see now I have five columns: age, salary, gender, experience level, and year. So in year, I have some random values from 2010 to 2020. Now, if I want to visualize this, I can say, okay, year, salary, and year, age. That means for each year, I want to see what is the salary, what is the age. This marker O means it will be represented by a hollow circle. S means it will be represented by a solid circle. Label will be salary. For this, the label will be age, and other labels, etc., are same. So if I run this, I can see, okay, since this is a very random data, so it shows how with each year age is increasing, and for each salary over time, how the salary is increasing. So this is the line graph which we can plot over time. Then we have covariance. So covariance measures the extent to which two variables change together. That means if there is a change in one variable, what will be its effect on the other variable. So we can see with age and salary, this is the values. So if you see, these are some exponential values that we are getting, and it shows how age and salary is related to each other. Since we do not have a very specific data set, so it is showing values like this. Otherwise, you will get some values in the range according to your data set, right? So this is how we do bivariate analysis, where we have seen that how we find the relationship between two variables. Now, if I want to find out the relationship between more than two variables, I will have to use multivariate analysis. So let's see how multivariate analysis is done. Okay. So in multivariate analysis, there are two major techniques that are used in multivariate analysis. The first type of multivariate analysis is pair plots. The other one is principal component analysis. So again, for this, we have to import the standard libraries, pandas, numpy, matplotlib, and cbon. Along with that, we have to import two more libraries. So there is sklearn, that is scikit-learn dot decomposition, which from that we import PCA, which is principal component analysis. So PCA is imported from scikit-learn, and in scikit-learn we have another uh, package which is standard scalar, so we have to import that. So I'm going to run this so that we import the required packages from Python. Right, so it will take some time in importing. Once it is imported, you will have these packages available in your notebook. Okay, so these are important. Now we will have a data set where we have age, salary, and we have added another column which is spending score, and there is a gender column. And again, we are converting it into a data frame. So now my data frame has age, salary, spending score, and gender. So this is the data set that I have. Now we will see how a pair plot can be created. So in pair plot, we will be able to visualize relationship across several variables simultaneously. So earlier, when we were doing bivariate analysis, we were only able to see the relationship between two variables, but with pair plot, simultaneously we can see the relationship between several variables, multiple variables. So simply we have to use SNS dot pair plot, which is the function available for creating a pair plot. The DF, that is the data set I am giving. Hue is equal to gender, that means that is the color that I am providing for gender variable, and diagonal kind is KD, that is the kernel density. So this smooth plot so that we get. And now if I run this, so you can see it is showing me the relationship between different variables. So over here it is showing me the relationship of age with different variables. Then it is showing me the relationship of salary with different variables. Then it is showing me the relationship of spending score with different variables. So this way, what we are able to do is we can see the relationship between multiple variables at a single point of time. Earlier, we were just able to see the relationship between two variables or a single variable. We were analyzing using univariate analysis. Then with bivariate, we were able to find out the relationship between only two variables. Now with the help of multivariate analysis pair plots, we can see the relationship of multiple variables within a single frame only. Then the next type of technique that we have in multivariate analysis is a principal component analysis. So principal component analysis is used for dimensionality reduction. and it helps us to simplify large data sets while retaining as much variance as possible. That means when suppose I have a high dimension data set, I have a 10 dimensional data set, and I want to bring it down to 4 dimensions only. So when I want to do such kind of dimensionality reduction, I am going to compute the PCA. So internally, what PCA does is it finds out a transformation function which is going to transform the 10 dimensions into 4 dimensions. So with the help of this lowering the dimension, we are able to capture multi-dimensional data without losing any data. So it preserves the variance in the data, but it reduces the dimension. So doing PCI in Python is very simple, but there are some pre-steps that we have to take. So first thing is we have to standardize the numerical features. That means we have to use the standard scalar that we have imported from the scikit library. So I'm taking a variable scalar is equal to standard scalar, and my numerical data has, so in PCA we use numerical data only. So numerical data is age, salary, and spending score. And then I say scale data is equal to scalar dot fit underscore transform numerical data. So why I am doing this is because age, salary, spending scores, currently they are all in different range. Salary is in thousands, age is in between 20 to 50, and spending score is again between 1 and 100. So I want to normalize them. I want to bring them down to a common range so that I can apply the transformation on them. So I have scaled data. So I have scaled all the values, and then I apply PCA. So for applying PCA, simply you have to use the function PCA, and number of components is equal to 2. That means I want to compute two principal component analysis. I want to bring down to 2. PCA result is equal to PCA dot fit transform scaled data. So whatever data we have scaled, we are feeding it into PCA dot fit transform function, and it will transform it. And then I'm saying PC underscore DF is equal to DF dot PD dot data frame PCA result columns principal component 1, principal component 2, and then I'm saying PCA dot PC underscore df gender is equal to df gender. So we are adding gender for visualization, and whatever PCA we have calculated, we are going to plot that. So if I run this, so I will get the results of PCA. So earlier, if you see, we had multiple features. Now this is converted to two-dimensional data because we have used only two components. So we had three dimensions over here. When we have taken the data, there was age, salary, and spending score. But we wanted to convert it into two-dimensional data. So now I have two dimensions only, principal component 1 and principal component 2. So my 3D data is converted into 2D data using PCA. So this was about multivariate analysis. So we have seen how in Python we can do univariate analysis, bivariate analysis, and multivariate analysis. Now I will quickly show you a data set that we are using from CSV file and how we are applying EDA. Right, so there is a case study that we are going to take for exploratory data analysis. And the case study of exploratory data analysis is done on used cars data set. So in this notebook, we are going to provide a step-by-step guide for performing exploratory data analysis. And I will share this file with you if all of you need it. I will share this also. So again, we are using the data sets, import pandas as PD, import numpy as NP, import matplot, pyplotlib, cborn, and import warnings. And then I'm saying warnings ignore so that I don't see unnecessary warnings when I'm running the code. Once we import all this, then the next step is since my data set is on Google Drive, So I will mount my Google Drive. So for mounting the Google Drive on Google Colab, we have to run this command drive.mount content drive. And once it authenticates your drive, it will show you your drive. Now, after importing the dataset in my drive, I have used cars.csv. So let me just run this. Right. So once I import it, then on my drive, then I will see over here. So I will connect to Google Drive and all this authentication I have to provide. Once I provide this authentication, Google Drive will be loaded in my dataset. I'm sorry, in my Python library. Right, so I have done this, and now if I see, so this drive is loaded, and within my drive, I have uploaded this CSV file used underscore cards.csv. So if I will show you this, in this I have a CSV file which is used car. So this is the used car.csv. I will just click on this and I'm going to copy the path. Once you copy the path over here, I can paste this path over here. So if I will paste this path, this is the path that I have. And now earlier, if you see, we were creating the data frame. Now we are directly reading the data frame from a CSV file. So directly from the pandas file, I am going to read the CSV file. And now this CSV file, I can directly analyze this CSV file in my code. So I am going to run this. So I'm saying data is equal to pd dot read underscore CSV. So in pandas, I have a function read underscore CSV, which helps me in reading the uh, data from the CSV file. So used cars.csv, and I have written data.head. So when I have data.head, in that case, there are it will show me the first 5 or 10 rows of my data set. So this is the kind of data set I have, where I have uh, brand, model, model year, mileage, fuel type, engine, transmission, and number of features are there. So all this is shown in my table. Now, after reading the data set, if I want to do some exploratory data analysis, I'm using the info function data.info, data.describe. So these are going to show me the description of each of the column, what is their data type, how many values do they have. So all this is shown. So I'm going to quickly go through it because we are reaching the time limit. Then if I want to remove some unnecessary columns, I can remove the unnecessary columns from my data set. Then suppose I want to create a new column into it, data, car, age. That means I want to calculate the age of the car. So I can create a new column also in my data set where I'm subtracting the current year from the model year of the data. Then we can do some feature creation also. So that means suppose fuel type, and in fuel type I have seen there are some NA values. That means some blank values are there. So I'm filling those unknown values with the value unknown, and in place is equal to true. So what it will do, it is going to replace these values in that data frame itself. Similarly, accident, if there is some null value, I am going to fill it with no, sorry, NA value. That means there is no value over there. And clean title, so I'm going to fill it with no. So these are some techniques by which we fill in the missing values. Similarly, data cleaning can also be done. so we can see if there are any outliers or not. If there are any outliers, I'm using a KDE plot that we saw earlier to see the distribution of car age. That means what is the range of my car values. And I'm also creating a count plot. So I've combined the count plot and KDE together to see the distribution of car age in my data set. And you can see this is the count of cars by fuel type. So it is showing me what are the cars with different types of fuel that I have. It is showing me a bar graph over here. Then if I want to do univariate analysis, so again, the same functions that we studied, like I can calculate a box plot, a scatter plot to see how the values are changing. So I can see in price, there are some outliers also over here. So with the help of box plot, we can see that. Similarly, we have created a scatter plot for different fuel types. Then we can do bivariate analysis where we are creating the heat map. So in the heat map, we have taken car age and model year. Then we can do some multivariate analysis where we are doing correlation. Right, so this case study is basically doing different kind of exploratory data analysis on real data, which was a CSV file, and we have seen how to apply different things. This EDA can be done in more detail also with the available techniques. So since we have limited time, so I've shown you a short example. If you want, you can explore more. I will share the Jupyter files with all of you. Uh, I'm ready for any questions if you have. So if in case you have any questions, any queries, anything you want to discuss, you're most welcome to do that. Okay, I think Jagat is raising his hand. Yes, please, Jagat.
You can please write in QA section, Mr. Jagat. Akansha ma'am, please refer to QA section for their
Okay.
questions.
Okay, so Jagat says data set share please. Okay, I'll share that. Not a problem. So this EDA technique I've shown you are example Jagat, and I will share these Jupyter files with also with you so you can go through them. Any other question, if anyone has, please you can write it in the QA box and I'll be happy to answer.
I
Okay, so
think
Jagat,
no more question.
EDA files example. So I'll share all these files with all of you. I'll share with the organizers. They will share it with you.
Thank you, Akansha ma'am. That was really a wonderful session on EDA. Really, it will
I
be
think
very
there is
informative.
one more question, Seema ma'am. So let me answer that also.
Okay, ma'am. Okay.
Okay, so somebody is saying if it is image data set means how do EDMM? Okay. So whenever you have an image data set, if you're dealing with images, since we have talked mostly about numerical values and categorical values, when we will talk about the image data set, so in image there are different techniques for first of all in image you won't require any EDA as such. You will require noise removal, you will require some kind of enhancement in the images because that is the kind of techniques that you need when you are dealing with image data set. So there are techniques for noise removal in images like the filters that we have different filters. You can use that. So they are considered as EDA noise detection techniques in images. Then in image sometimes the contrast of the images is low. So you have to use techniques like histogram equalization, image enhancement, contrast enhancement. Those kind of techniques can be used for images. So these techniques that we were talking over here is mainly for numerical and categorical values. I hope that clarifies your question. Okay, so Jagat is saying PPT is too. Okay, I'll share everything. That is not a problem. Okay, then thank you.
Thank you, Akansha ma'am. This was really informative session on analysis part. Definitely, the participants will be getting benefit out of it. Thank you so much, ma'am.
Thank you everyone for listening. Thank you.